Hi, I'm David. So for this problem, we're given the function g of x is equal to -1 over x plus 2. And they want us to compare this function to f of x is equal to 1 over x. Now this is the parent function for this function, right? In other words, this is the function that this g of x function is based off of. This is the most basic form of this type of function. It's just that this function happens to have a few alterations that makes it look slightly different. So first, before we graph this, let's look at what the basic parent function looks like. So whenever we graph these types of functions, we have to graph the horizontal and vertical asymptotes first. So it has a horizontal asymptote at y is equal to 0. And also a vertical asymptote at x equals 0. And all that means is that an asymptote is a part of the graph where this function will never touch. It will approach it, but it will never actually intercept at any of these asymptotes. Now, this function looks something like this. Right? And so what that means is this part of the line will go forever infinitely in this direction and get closer and closer and closer to the asymptote, but it'll never touch it. Same here. This will go forever infinitely upward and get closer and closer and closer to the vertical asymptote, but never touch it, and vice versa here. It'll go negatively, never touch it. Here it'll go negatively and never touch it. Now, why do these asymptotes exist? Right? The reason for it has to do with the fact that the x is in the denominator of the fraction. As we recall from previous algebra lessons, we're not allowed to have a 0 in the denominator of a fraction. We can't divide by 0. That would give us no solution or null set. Right? It's physically impossible to divide by 0. That means we can't plug 0 into this function. Right? That's why at 0 we have an asymptote. Right? There's nothing that exists here. Meanwhile, let's plug in a few numbers to show you why this function gets closer and closer to this line, but never touch it. Let's say we plug in a 1, right? Let's say we plug in 1 for x. That'd be about here. If we plug in a 1 for x, we get 1 divided by 1, and so then the answer is maybe roughly 1. Let's say that's 1. What happens if we plug in 2? If we plug in 2 for x, we get 1/2. So 2 is here. So then now we go a little bit, maybe roughly here is where it is, right? That's half of where we were previously. If we plug in a 3, it goes to 1/3, right? This pattern continues infinitely. When we go to, let's say, x is equal to 1,000,000, all of a sudden we get 1 over 1,000,000, which is really small down here in the corner, right? And no matter what number we plug in for x, this will never go to 0 because we have a 1 on top in the numerator. And so for that reason, we have a horizontal asymptote at y equals 0. Right? Same thing going negatively. If we were to plug in negative numbers, the same thing will happen. That no matter how small of a number we plug in for x, this fraction is only going to get smaller and smaller and smaller, but it will never actually go to 0. Right? That's why these asymptotes exist. And now let's look at this parent function and now just change it up a bit and graph this new one at g of x. So this one, the difference here, as you notice, is we have a +2 and a negative. This +2 means that we're taking this parent function and shifting everything upwards by 2. So every point here is going to go up by 2. Meanwhile, this negative symbol means that everything is going to be reflected, meaning everything is going to be flipped on the horizontal axis, on the horizontal asymptote. So again, let's graph the asymptotes first. First, let's graph the horizontal one. So this we know is going to be up 2, right? So that means we have a horizontal asymptote, something like this. Meanwhile, we still have a vertical asymptote that is at 0, right down the center. Right? But instead of having it look like this and this, like this one, everything, remember, is being flipped. Everything is now the opposite because of the negative symbol. So now instead of it being here, it is now here. And instead of everything here, we're, again, reflecting it on the horizontal axis, on the horizontal asymptote. So this is now the final graph for the g of x function. And that is how we solve this problem. Thank you.